In this video, I will show synthetic division for the same polynomial that we divided by x minus 3 a couple of videos ago with long division. So we have x minus 3 is still the divisor here. But remember, in the form of factored form x minus r, the binomial, we have r equals 3. So we put, the first step says, put 3 up in a little box to the left. And then step 2 says, list the coefficients of the polynomial, which is the dividend. So we have 2 for the x cubed term, -1 for the x squared term. We don't have an x to the first degree term, so that's that don't forget, put a placeholder in for missing terms in step 2. So we put a 0 for x to the first degree, and then I have a constant of 3. Now I like to draw an evaluation bar there before I move on to step 3, and then I bring down the leading coefficient of 2. Then I multiply 2 times r, which is 3. So 2 times 3 is 6. Then I add -1 and 6. That's positive 5. Then I keep repeating until I'm finished with all the columns. So 5 times 3 is 15. 0 plus 15 is 15. 15 times 3 is 45. 3 plus 45 is 48. So now I know I'm done. I'm out of columns. So 48 is the remainder, which if you look back in your notes, we already saw that 48 was the remainder through long division. And then as we look to write down what is the quotient, we have all the coefficients of the quotient. We started with an x cubed polynomial. So that last statement, the quotient, which is a depressed polynomial, is always exactly 1 degree less than p of x because we divided by 1 degree of x. Now the leading coefficient will be 2 for an x squared term, then plus 5x plus 15. And if you look back in your notes, that's what we got for the quotient. And we would check this the same way. So we have the quotient here. We have the remainder of 48. So to check it, we need to make sure that x minus 3 times the quotient, 2x squared plus 5x plus 15, then plus the remainder, which is 48, equals the original problem. We already did this math. We took x and distributed times each of the terms. We took the -3 and distributed it times each of the terms in the quotient, and then we added the 48. So we got 2x cubed plus 5x squared plus 15x minus 6x squared minus 15x minus 45 plus 48. That should ring some bells. And then we gathered like terms and got 2x cubed. Remember our x squared, 5x squared minus 6x gave us the minus x squared. Our 15x and -15x canceled each other, and then we had plus 3 with our two constants adding together. So it should be no surprise that we get the same answer as we did with long division. Again, synthetic division just lends itself to be less error prone because we're multiplying and adding instead of multiplying and subtracting. We're just taking the divisor and changing it from its factored form to just dividing by the root itself, the 0 itself.